These are the most frequently asked questions for Algebra 2 for section 11.3. I'm going to start with number 17. And number 17 says reading. Suppose you have 5 books in your book bag. 3 are novels, 1 is a biography, and 1 is a poetry book. Today you grab 1 book out of your bag without looking and return it later. Tomorrow you do the same thing. What is the probability that you grab a novel on both days? So I'm going to think of this as, all right, I've got a probability on day 1 of getting what I want, and then day 2, I have a different probability. Maybe. We'll see, because we have to read through this and figure out whether or not these are independent or dependent events. So for number 17, it says we want to pick out a novel. So we think about, okay, well, how many novels are there out of how many total books? And we realize there's 3 novels, and then we have a biography and a poetry book. So there's a total of 5 books, and 3 of them are novels. Now, we want to read and catch the part where it says, hey, did we put it back, or did the situation change, and now there's a different amount of outcomes for the second situation. And we notice right here, it says you returned it later. So you did put it back in your bag. That resets the situation. We are back to the same beginning that we were at before. We still have 5, with 3 of them being novels. And since we want this to happen one right after another, it's one and the other. We want a novel the first day and the second day. We would multiply those together. Top times top, bottom times bottom, and we would get 9/25 for number 17. The next one I wanted to go through with you was number 27. And number 27 says we've got a standard number cube that's tossed, and that just means we have from 1 pip to 6 pips on there. Find each probability. 27 says it's an even number or it's less than 4. So first I would think about the evens that are on there. And that's 2, 4, and 6. So there are going to be 3 out of the 6 that are going to be even. Then I want to add, because this is an or, all the numbers that are going to be less than 4. Well, that's going to be 1, 2, and 3. Those are the numbers that are less than 4 on a standard number cube. So that's 3 over 6. But remember, with or, we have to subtract any number that's been counted twice. So I'm always glad that I write my options down when I do these, because it's very easy to see when you have something in the overlap, something that is in both groups. And that's going to be the 2, so that's 1 out of 6. And now you can see, I'm also really glad that I didn't do anything with the denominators here. I didn't reduce my fractions, because when we're going to add or subtract, we want to wait and see what happens. So 3, 6 plus 3, 6 is 6, 6. And 6, 6 minus 1, 6 is going to give us 5, 6 for our answer. So that was number 27. Number 32 says, suppose a number from 1 to 100 is selected at random. What's the probability that a multiple of 4 or 5 is chosen? So in number 32, what I want to figure out is, what's the probability I'm going to get something that's a multiple of 4, plus the probability that I get something that's a multiple of 5, but then I have to subtract anything that's in the overlap. It would be multiples of both 4 and 5. So that's what my counting needs to do. And if you're thinking, okay, let's see you do this one, Cedar Home, write down all the numbers from 1 to 100. I'm not going to do that, because I know that the multiples of 4, if I want to find those, if I want to find the amount, all I have to do is take 100 and divide it by the number that I need the multiples of. So if I want the multiples of 4, I'm going to take 100 and I'm going to divide that by 4. There's going to be 25 of those out of the 100 numbers. Now, if you're also thinking, hey, wait a minute, aren't there really 101, or maybe there's 99 numbers from there? If we want the total, what we always have to do is take the largest number, subtract the smallest number, and then add 1. And that's because we want to make sure that that 1 gets counted. And if we just subtract, we're saying that 1 is not important to the problem, and it is. It is. So we have to count that in there as well. All right, so far I've got my multiples of 4, and then I need to add my multiples of 5, so that's going to be 5 dividing into 100, and that of course is 20. And then I think, okay, well, how am I going to know if it's a multiple of both 4 and 5? Well, all you have to do is multiply 4 and 5 together, and you see that's going to give you 20. So anytime you have multiples of 20, or basically 20 as a factor of 100, you're going to get a multiple of both 4 and 5. So one more time, we'll take 100, and we will divide that by 20, and that will give us 5. So this is going to have to subtract what was in the overlap there, which basically is our 20, 40, 60, 80, and 100. Those are the numbers that would be multiples of 4, multiples of 5. So they cover both of them. And those are the ones that are double counted. So we have 25 over 100 plus 20 over 100, which is going to be 45 over 100. 45 over 100 minus 5 over 100 is 40 over 100. You can divide by 10 right away and get that down to 4/10, and then of course you can go further, dividing both of those by 2 and get 2/5. So our final answer on this one is 2/5. Takes a little thinking, but not necessarily the hardest problem in the world once you realize your patterns that you're looking for. You could just find by division, figuring out how many of those factors you have. Then 35 and 36, I like these two problems because they get you thinking about when you have all of something, you have 100%. So number 35 says a person is not in production, transportation, and material moving. So here's production, transportation, and material moving. And what I don't want to have to do is add the 10.8, the 24.8, the 16.5, and the 35.5. I'd rather do this the easy way, which is to say, when you have 100% of something, that counts as 1. So if I take 100% or 1, and I just subtract here, that will get me what I need. So remember, if we're working with decimals, we want to use a 1. If we're working with percentages, we want to use a 100. So all we would have to do in 35 is just take that 100% minus 12.4%, and that will give us 87.6%. Number 36, we have a person is neither in service nor in sales and office. So I'm going to use that same kind of thinking here to say, all right, I have 100%, but what I have to do is I have to subtract the people that are in sales or, service or sales and office. So service, sales and office, that's what I'm going to want to subtract from that. So 24.8 plus 16.5, and then we'll just subtract that from 100. So that's going to be 100 minus 41.3%, and that comes out to 58.7%. So a little easier to do your addition first, and then just do a little bit of subtraction there, rather than adding up all of the numbers that we don't need at any given time. And of course you always could just add the other ones together, and that will work as well. Then we have a jar, and that jar contains 4 blue marbles and 2 red marbles. Suppose you choose a marble at random, and here's the key. Do not replace it. Then you choose a second marble. Find the probability of each event. So these events are dependent because we're not putting that marble back. So 37 says we're going to choose a blue marble, and then we're going to choose a red marble. So the first thing we do is think, okay, jar is full like they say it is. We need a blue marble. Well, there's 4 blues out of 6 total marbles. Now, we're not putting that marble back. We got a blue marble, and we're going to set it out on a table. And so now there are only 5 marbles to choose from, and we have to figure out how many of those are still red. Well, remember, we picked a blue marble, so both of the red marbles are still in there. And now because we're going to multiply here, we certainly could reduce that 4/6 to 2/3 right away, or you can do some reducing or cross-reducing at this point. It doesn't make any difference. But I think seeing that you have 6 for your total outcomes in the first fraction makes it easier to say, oh, yep, look, I took care of that. There's only 5 marbles now since one of those did not go back in the jar. So I would reduce this to 2/3. And then it's just top times top, bottom times bottom. So for number 37, 4/15 would be the correct answer. For number 38, we're going to get a red marble, and there are 2 out of 6. And then we're going to get a blue marble. Well, we took that red marble, we set it down on the counter, so now there are no longer 6 marbles in the jar, there are only 5. But you know what? We took a red one before, so all 4 of those blue marbles are still in there. And again, at this point, you could go ahead and reduce your 2/6 to 1/3. And then top times top, bottom times bottom. And you get 4/15. Number 39. 39 says, one of the marbles you select is blue and the other is red. All right. So what we have to figure out here is that this is really an or situation, because it could be that we get a blue marble, then we get a red marble. Well, it could be that we get a red marble and then we get a blue marble. So we have to take care of both of those situations and then add them together and see what we get. So for number 39, we're getting a blue marble and then a red marble. So here we go. Blue marbles, 6 marbles all together. And we have 4. And then, since we took a blue marble out, there's only 5 left, and 2 of those are red. And you should be saying to yourself, wait a minute, I already did that math up there in number 37. Yes, we certainly did. We did blue marble and then a red marble. So no surprise that that comes out to 4/15. We want to add to that what happens if we get a red one first and then we get a blue one. All right, so a red one first, 2/6. There's only 5 in the jar, but 4 of them are blue. And again, you realize you already did that math in number 38. So that's 4/15. And then what you have to do is stop for a second and say, is there any way for both of those situations to happen at the same time? And the answer to that is no. You can't get a blue and then a red marble at the same time, get a red and then a blue marble. It's not going to happen. So this is an or situation, but they're mutually exclusive, so we don't have to subtract anything from that at all. And of course, that's just going to give us 8/15 when we add those two together. So kind of a strange problem, because when you read through it, you don't see the word or in there anywhere. But as soon as you think about it, they're really 2 separate events that they're talking about here. Getting a blue and then a red, and then the other situation is getting a red and then a blue. So we have to add those 2 together since they are different situations and they cannot happen at the same time. Then for number 40, both of the marbles you select are red. Okay, so we go back to the beginning, and we know there are 6 marbles, and we know that 2 of them are red. But now, the marble that we had was red, and we set it down on the counter, and there are only 5 marbles still remaining in the jar. And because one of the marbles we took was red, there are no longer 2 red marbles in the jar, there are only 1. So with this one, again, we could do a little bit of reducing and make our 2/6 1/3. And in the end, top times top, bottom times bottom is going to give us 1/15. So kind of interesting problems there about pulling marbles out of a jar. Now number 41 says, for each set of probabilities, determine if the events A and B are mutually exclusive. Being mutually exclusive means that the probability of A or B has to come out to be 0 for the overlap. So probability of A or B equals the probability of A plus the probability of B, and then minus the probability of both A and B. if they're mutually exclusive, that number will be 0. So we check this in the formula, and this is the probability of A and this is the probability of B. We need to add those together and see whether or not they equal the probability of A or B, or if it's different. Because if it's different, that means there was a value for the overlap, the probability of A and B. So 1/2 and 1/3, our least common denominator will be in sixths. So that will be 3/6, and then 1/3 would be 2/6. And if we add those together, we get 5/6. So we look at the probability of A or B, and it's not 5/6. So for number 41, those cannot be mutually exclusive. There has to be something that's being subtracted in order to get that 2/3. So this is a no. They are not mutually exclusive, because we can see that in order to get that 5/6, there would have to be some additional math taking place over there in this position of the probability of A and B. 5/6 minus something would have to give us the 2/3, and in fact, we can even tell them what that something is. It would need to be a 1/6. So the probability of A and B would be 1/6, which of course means they are not mutually exclusive. Then 48, nice review problem. I mean, it's a pretty basic algebra, but I just want to make sure that nobody forgets what we're doing. And that's just find the slope of this. To find the slope, what we want to do is get y equals mx plus b. Because when we do that, we know the slope is located right in front of the x coordinate. So what I need to do here is subtract 6x from both sides, because I'm solving for y. Negative 18y equals negative 6x minus 24, and then divide everything by a negative 18. So y will equal a positive 1/3 x plus, and you know what, I don't even really care what 24 divided by 18 is, because all they wanted was the slope. But we certainly could go ahead and do our reducing there. So 24 over 18, 6 goes into each one of those, and that would give us 4/3. But like I said, we already found our answer. There is our slope right there in number 48. So the slope is 1/3. Then for number 50, it says, how many 5-letter permutations can you form from the letters of the word computer? All right, so definitely going to be P for permutations, and I need a total. Well, this is the word I'm supposed to use right here, so I better count up how many letters I have to choose from. 1, 2, 3, 4, 5, 6, 7, 8. 8 total letters, and I want 5 for my permutation. So this will be 8 factorial over 3 factorial, which will be 8 times 7 times 6 times 5 times 4, because the 3 factorial piece is just going to cancel out. And that comes out to 6,720 permutations. Then number 60 says, a spinner has 4 equal sections that are red, blue, green, and yellow. Find each probability for 2 spins. So I take a look at number 60, and it says we want blue, and then we want another blue. So this is going to be an and situation. It's one and another. You know, we want the blue, then we want another blue. So we look at it and we see there's one blue out of 4 different colors. So 1/4. Now, just because we got blue on the first spin doesn't mean we're not going to get blue on the second spin. It's kind of like watching Wheel of Fortune and seeing somebody that continually ends up landing on bad stuff. It's because their spins are giving them that 360-degree rotation, and they're landing up exactly in the same place. So we had 1/4 for the first spin, and it's still going to be 1/4 for the second spin. So that will be 1/16. And that is going to do it for 11-3.